Hey, what's up, guys? Welcome to day 3. We're going to continue in our review toward the SOL, and today we are tackling the topic of functions. All right, so let's get straight into it. Okay, I'm going to review by answering these frequently asked questions. Right? Is a relation a function? What is Dixieroid, and why is that important? What is slope-intercept form? How do I graph a function? Is a slope, does it have positive, negative, or zero? Or how do I determine if it's what the independent or dependent variable is? And so those are the 6 questions that we're going to cover in this review. All right. So question number 1, is a relation a function? Okay. And so functions can be shown in different ways. They can be shown as a table, input, output. It could be shown as a graph. It could be shown as ordered pairs, right? So we got to keep that in mind. But the important thing to remember is a relation is a function if the x values do not repeat, okay? So the x values, in other words, for every input, there must be one output, all right? For every x value, there can only be one x value for every y value, okay? And so if the x's do not repeat, then it is a function, okay? And so if a relation is not a function when the x's do repeat, okay? So if from looking at a table, if there's multiple x's if there's the same repeating value for the x, then it is not a function, okay? And we're gonna see this in the different ways, but again, you need to remember the x's cannot repeat in order for it to be a function. For every x value, there's one y value, okay? Now, I mentioned there are various ways that you can see functions sort of given and how they are described. And so what is Dixieroid? Dixieroid is just kind of a way to remember what each of the 2 variables might be referred to. Okay, so the Dixie side refers to all of the x values. So the x values can be referred to as the domain. The I represents the input. The x is the x value, and then I is the independent variable, okay? And so these are all of the different terms that you can use to describe the x value, okay? And then the roid is the terms that you can use to describe the output or the y, and so it is often referred to as the range, the output, the y value, or the dependent variable, okay? So it's important to remember these are the various names that you may use to refer to each of the two numbers in relationship, okay? So that is Dixieroid. These are really helpful for you to remember, to know which names describe each of them, all right? Now, what is slope-intercept form? Okay, so slope-intercept form is a way of writing a linear equation where the slope, which is the m, and the y-intercept is used. Okay, so it's writing a graph, a function, using the y-intercept and the slope. Okay, and so you need to remember that slope is rise over run. Okay, and the y-intercept is where the graph crosses the y-axis. Okay, so when you have y equals mx plus b, that is slope-intercept form. The y is the y value. Okay, the m is the slope. The x is the x value. And then the b is the y-intercept. Again, where it crosses the y-axis, okay? And so I have this graph over here, and I'm just going to write it in y and slope-intercept form. Y equals mx plus b. Well, the y-intercept, where it crosses the y-axis, is at -3. So my b is going to be -3. Okay, that's my b. Okay, y equals mx, again, plus b. Then my b is -3. And then I got to figure out what my slope is. Well, to figure out the slope, I need 2 points on my line. And then again, remember, slope is rise over run. So I go to 2 points. I could pick any 2 points, but I'll start with these two, and I'm rising up 2. So I'm going up 2. That's the rise. And then I'm going back 3. So up 2, and then I'm going back 2. So that is going to be a negative 2. Okay. So negative 2 over positive 2 over negative 2. And that is, if I simplify that, that's just going to be 1. 2 over 2 is just 1. So my slope in this case would be a negative 1. So negative 1x is my slope there. Okay. And so this is y equals mx plus b slope intercept form. And again, what I see is this is a way of displaying this graph right here. Okay, so slope intercept form is a way of writing what this graph, what this function would look like. All right, let's continue on. Okay, so how do I graph a function? Well, I just kind of showed you a little bit in the last example, but if I am given an equation in slope intercept form, all right, what I want to do is I want to start by graphing the y-intercept. So I start by graphing the y-intercept, which is the b, all right, and then I find the other points by using the slope, which would be the m. Okay, so in this example, the slope is the 1/2. Okay, the y-intercept is the -3. Okay, so I'm going to start by graphing the y-intercept. That is, again, where it crosses the y-axis. So I go down to -3. Let me choose a different color here. Okay, so I'm graphing this at -3. Okay, now then I'm going to use, again, y-intercept is where it crosses the y-axis. Now I'm going to use my slope to find the other points. So slope, rise over run. So I'm going to go up 1 over 2. So up 1 over 2. Up 1 over 2. Up 1 over 2. Okay, and then I just connect those lines, and that is how I graph. Okay, and so, you know, because your SOL will be on the computer, you will need to identify them. But, you know, still, when you think about it, start by looking at the y-intercept and then figuring out, okay, the slope and seeing if the other points fall, see where they fall. Okay. All right. So that is for how do I graph a function. Okay. Now we need to know if I have a slope that's graphed. Okay, is it a positive slope, a negative slope, or a zero slope? So these are the different types of slopes. And so if a slope increases from left to right, then it is a positive slope, all right? So again, positive slope is that it increases from left to right. So as I'm moving from the left, it is going up. It is increasing from left to right, all right? If a slope decreases from left to right, okay, meaning I'm starting up top, and then I am going down. I am decreasing from left to right. That would be a negative slope. And then if I have a slope that is horizontal, all right, if it is not increasing, not going up, not going down, but let's just say it is sort of flat like that, that is a slope that has what is called a zero slope. Okay, there is one more type of slope, but you don't need to know what that is for this year. So those are the 3 types of slopes that you will see: positive, negative, or zero. Okay. All right. And then lastly, whether or not a variable is independent or dependent. And what you need to know is the independent variable, it causes the dependent variable, okay? In other words, you want to think about one way it is good to think about this is cause and effect relationship, right? And so the independent variable is the cause. The dependent variable is the effect, okay? So again, if I'm thinking about this, the independent variable is the thing that causes, or the thing that leads to, or the thing that affects the other. All right. So let's think about it in this next problem. All right. Or we got a couple examples here. Studying for a test and your grade on the test. Right. Well, again, just think about it. Right. The more you study, right, or don't study, that is going to affect or impact your grade. So in this case, right, studying is the thing that causes the grade on the test. So studying would be the independent, or the amount of time that you study would be the independent variable, okay? And then the grade would be the dependent variable, okay? That would be the dependent variable, all right? And let's look at the next one. Running miles and burning calories, right? So again, if we think about, does the running the miles cause calories to burn? Or does calories burn cause a person to run more miles, right? Again, just thinking about this, the more miles you run, that is the independent, that causes the calories to burn. So the calories would be the dependent variable, okay? Again, so if we just think about the relationship, which one causes or leads to the other, all right? And then lastly, selling cookies and earning money, right? Does the selling cookies cause you to earn more money, or does earning more money cause you to sell more cookies? Okay, again, hopefully we see it is the selling of the cookies is the independent, and then the money is the dependent. Okay, so again, in these examples, the independent variable always came first, the dependent always came second. That won't always be the case in various examples. Wanted you to just see them. Again, all of these problems are going to be different because they're talking about different situations. All right. So, guys, that is the end of this review. And so, in this review, we learned or we were reminded of the big ideas, the big topics for the functions unit. Hopefully this helps you do practice some examples, and let me know if you have any questions or if you need anything explained. You can like it, you can comment it, let me know. Happy studying.